Hello there. We are from Section 9, Group 6, and we are going to present about what we have made of our movie recommendation engine. And these are our group members. I am Muhammad Firdaus, AA221231, Amira Natasha binti Salihin, AA221715, Vivian Beryl Anak Robinson, AA221651, Khairina Batrisha binti Zunaidi, AA220954.
Hi and Assalamualaikum. I'm Khairina and I will start this presentation by explaining what a movie recommendation engine is. So it is an engine that suggests films to users based on their preferences and behaviors by using algorithms such as collaborative filtering, which analyzes patterns in user behaviors, and content-based filtering, which recommends movies with similar attributes to those that user had liked. Hybrid approaches combine both methods. These engines provide personalized movie suggestions, which is really important in terms of enhancing user experience and engagement on any streaming platforms.
In cell 1, we have two datasets, which is datasets name movies and credits. We did some pre-processing such as merging both the datasets and only taking the relevant columns that we really want to use and ignore all the unnecessary columns. Then we did some functions to convert the data from the datasets into actual processable words, and in here we can see the result of what we have did by merging the datasets. We have ID, title, overview, genres, keywords, cast, production companies, vote average, vote count, release date, runtime, and text. This is the example of the data by using movies.head.
For this step, this code utilized machine learning technique to compute the similarity between movies based on their textual features. It starts by importing the count vectorizer and constant similarity from the sklearn library. The count vectorizer is configured to consider a maximum of 5,000 features and to exclude English top word. This vectorizer transforms the tag column of the movies data frame which contain combined and preprocessed tag data for each movie into a numerical features vectors. The resulting vectors array represent the frequency of terms in each movie tag text. The constant similarity function is then applied to these vectors to calculate the constant similarity between each pair of movies. Constant similarity measures the constants of the angle between two vectors, providing a value between 0 and 1 that indicates how similar the movies are based on their textual descriptions. This similarity metric can be used for tasks such as finding movie like a given movie.
Moving on to the third cell of the code, we implemented a basic movie recommendation system based on user preferences and watch history. The functions in this code are display genres and collect user data. The display genres function outputs a list of unique movie genres derived from the dataset, while the collect user data is used to collect user preferences for movie genres and their watch history and ratings. The collect user data function will call the display genre function to present the available genres, and it will prompt the user to select their preferred genres by entering some corresponding numbers. It also gathers the user's movie watch history and ratings and verifies that the entered movie titles exist in the dataset. Unique genres are extracted by iterating through the genres column of the dataset and adding each genre to a set, ensuring each genre is only listed once. This set of unique genres is used by the display genre function to show available genres to the users.
So next, in cell 4, two recommendation functions are defined as recommend based on genre and recommend based on history. The recommend based on genre function filters the movies to those that match any of the user preferred genre on and return the top end movies which is default 10 based on the genre match. For the recommend based on history, its function to use the user's watches history and rating to find similar movies. So the final one, the recommendation from both methods that I stated at the previous slide are displayed using the display function. The genre-based recommendations are printed first, showing movies that align with the user's genre preference. Then, the history-based recommendations are displayed, which suggest movies similar to those the user had watched and rated highly. This is our output for our coding. We need to enter numbers of our preferred genres, and I choose 1, 4, and 5. And how many movies that I watch, I choose 3. And I choose title of movie is Avatar, and I need to rate Avatar out of 10, and I choose 5. And we need to enter more title movies, and I choose Spectre, and I rate 6 out of 10. And I need to enter title movies again. I choose John Carter, and I rate John Carter 4 out of 10. And it will display genre-based recommendation and history-based recommendation based on the movies that I enter.